45 minutes. We are doing week 2, lesson number 4, natural science. At the end of the lesson, I would like you to know more about density and what density involves and how mass and volume is related to density. Now, there's also density of different types of materials and also density in its states of matter. Before I continue with this recap, what I want you to know, I want you to raise your hand and you can tell me what you can remember from yesterday's lesson. Does anybody want to start? Yes, Andy. Hi. My host will unmute you just now. Hi. There is a lag between unmuting sometimes because that's a technical difficulty on Zoom side. Hi.
Hi.
You want to recap?
Yes, ma'am. So yesterday's lesson, you told us about how matter changes from a solid to a liquid to a gas and what the process is called. So from a solid to a gas, it is sublimate. From a solid to a liquid, it is melt. From a liquid to a gas, it's evaporate. From a gas to a liquid, it's condensate. And from a liquid to a solid, it's freeze.
Oh, that's very good. Excellent. Well done. Does anyone else want to have a turn? Well done for that. I'm very proud of you. John? My host will unmute you in a minute. Hi. There's also Levi. Anyone else would like to have a turn?
Ma'am.
Yes, I'm listening.
We also learned that how we add energy. We also learn about how we added energy to a solid and a liquid, and how a solid turns to a liquid and a liquid turns to a gas.
Okay, so that's adding energy. Very good. And if we remove energy, how does it go? It goes from a gas,
for example, liquid.
A gas to a liquid, and then from a liquid to a
solid.
Very good. Well done. I'm very proud of you. Excellent. Hello.
You could also say, for example, heating or cooling.
Okay, that's excellent. Yeah. Well done. So I'm going to do a quick recap. So we have changes are a state. Changes of state are usually the result of heating or cooling. When a solid is heated, it will change to a liquid, and this process is called melting. And when it is heated further, the liquid will change to a gas, and this process is called evaporation, what you guys said earlier on when I asked you to summarize, which is very good. I'm very proud of you. When a gas is cooled, it will change to a liquid, and this is called condensation. And when a liquid is cooled even further, the liquid changes to a solid, and this is called freezing. Now, I'm going to introduce density to you. The density of a material is a measure of its relative heaviness. So that means that how heavy an object is. The denser the materials have, denser materials have a greater mass in relation to their size. And this is why they feel very heavy. So let's look at it in this way. Have you ever heard the word density? Some of you may have said, you know what, this cake is really dense. But when they say this cake is really dense, what does that mean to you? So if we look at the picture on the right-hand side, now we have the, say these particles in little cubes. Now the picture on the left has less particles in it, and in the picture on the right in the cube has more particles in it. Now the one with the more particles makes something more dense as compared to the picture on the left, which makes it more heavier. Yes, Abu Bakr. Can I ask my host to unmute you?
Ma'am, I didn't raise my hand.
Oh, okay, I saw it raised. Maybe you did it by accident. Okay, anyone else?
I think for density, I think sometimes it also refers to like population and all that.
That's population density, which you'd learn in geography. But here
Yeah.
we're going to learn how heavy certain things in natural science. Okay,
Okay.
very good. Okay, right. So now we're going to ask ourselves, what is density? So density is how much matter is packed in a given volume. So now what does that mean to you? How much matter is packed in a given volume? Yes, who wants to speak? My host will unmute you. Hi. Hello. Okay, so I am going to continue. So we say if we look at the scale here, we have a large rectangular prism. Hello. Hi. Okay, so we have a large rectangular prism, and then we have which is say 1,000 moles, and then we have this little cube here, which is says it is 100 moles. So when we want to find out what the density of each of these are, we use an equation. So we say density is equal to mass over volume, that is mass divided by volume. So I'll explain this a bit more to you now. Density means how compact the mass in a substance or object is. That means how the particles are arranged in the volume of the substance. Now, like how much it takes up space. Now, the scientific definition for density is mass. Density is equal to mass divided by volume. Now, this tells us how much mass, which is matter, exists in a given volume. So, like on the picture on the right, we will find out how much mass is given in this square here, which is the grayish square, and we'll find out the density of it when we measure the mass divided by the volume, and then we'd find the density of the red square by dividing the mass and the volume. So in this section, it introduces us to physical quantities that is important for us to study in science. And these physical properties there are two quantities that namely make up the fundamental properties of density, which is mass and volume. And we're going to discuss them first, and it will help introduce you to the concept of understanding what density really is. Now, density is also a property of matter that is very closely related to the two. So if we have two bags of rice, now you could see one is a really huge bag of rice, and then you have the second one, which is a smaller bag of rice. Now, you can ask yourself, how much of rice is in the bag? Now, before I continue, who can tell me which bag of rice would be more dense? Does anybody want to give a chance? Hi, my host will unmute one or two of you. Hello. And don't feel bad if you don't get a chance to speak.
Hello, ma'am.
Hi.
Ma'am, I think the bigger bag of rice is more dense because it's bigger and it consists of more rice, which are very near to each other.
Yes, that's excellent. Very good. Well done for that. Okay, so mass tells us how much matter we have. So we looked at the picture of the bag, and one of the participants said that the one with the bigger bag has more density because there's a lot of rice in it, and these rice particles are close together. They're next to each other. Okay, so the mass of an object or a substance tells us how much of matter it consists. Now, the greater the mass of an object, the more matter it contains. So now, the greater the mass means that the bigger it is. It means that the more matter it would contain. Now, let's understand density in terms of mass. What do we mean of my mass? Now, mass is basically measured in kilograms. And now when we measure mass in kilograms, or if we measure mass in grams or milligrams, then we basically finding out the weight, how much it weighs, right? So 1 kilogram of mass equals to 1,000 grams of grams. 1 gram is equal to 1,000 milligrams. So now, who can tell me how many milligrams is equal in a kilogram? Hi. Hello. My host will unmute one of you. Hello.
Hi.
Hi. What would be the answer for how many milligrams are in 1 kilogram? So milligrams is 1,000 and 1 kilogram is 1. Hi.
Sound
Okay, can you
is there?
hear me now? Hello? Okay, so there seems to be have some technical difficulty with regards to that. So we're going to take, if you say 1 gram is equal to 1,000 milligrams, so then we're going to say 1,000 milligrams, you're going to multiply that to find out how much is equal to 1 gram, 1 kilogram. Hi? So if 1 gram is equal to 1,000 milligrams, and if there's 1,000 grams in 1 kilogram, so we take 1,000 and we multiply it with this 1,000, and then we will find out exactly. We find out how many kilograms would be in a milligram, in 1,000 milligrams. If one gold of bar has twice the mass of another gold of bar, then it contains twice as much of gold atoms. So that means that if we have two gold bars, that means that it has twice the mass. Okay, the mass of an object stays the same. When one gold bar has the same number of gold atoms, this means that the mass will always remain constant. So if one gold bar is 250 grams, how much do you think 1 kg of gold bar would be? That would be much easier than working out the milligrams into kilograms. Anybody wants to have an answer? Hi.
Ma'am, can you hear me?
Yes, I can.
It will be 0.25 kilograms.
For?
Isn't it gold bars each with a mass of? It will have a mass between of 250 grams, isn't it?
Okay,
So
one. So how many gold bars do you need to make 1 kg? If one gold bar is 250 grams.
You need 4 gold bars.
You need 4 gold bars. And your 0.25 kgs is correct when you had to convert 250 grams into kgs. Well done for that.
Thank you.
You're welcome. Okay, so volume tells us how much. We finished with mass. Now we're going to move on to volume. So volume tells us how much space matter takes up. The amount of space that an object has, it means that it occupies volume. Now volume is measured in liters, and it is calculated by measuring the length, the width, and the height, like in this picture that I'm going to show you. So if we had to calculate volume, we're going to measure the length, the width, and the height. Now, you may be a little bit confused because this is a cube, and then you're going to ask me, but she said something about liter. How much liters are in a volume? So we're going to see how much of liquid we can pour into this cube that we have here. Right. Did you know that it takes a cube takes basically 1 liter. Now you may ask yourself, how does this work? So if we look at the measurement, not specifically this cube here, but if we look at the measurement of calculating volume, so if you do it with the length, the width, and the height, which is the length times the width times the height, if we just take the basic 1 centimeter times 1 centimeter times 1 centimeter, it is equal to 1 cubic centimeters. Now, 1 cubic centimeters is as the same as 1 ml. Now, the volume of the cube is basically 10 centimeters. It has 10 centimeters in length, 10 centimeters in width, and 10 centimeters in height. And this basically equals to 1,000 centimeters cubed. So now if we had to convert that 1,000 centimeter cubed, now if 1,000 centimeter cubed is equal to 1 liter, just like 1 cubic centimeter is equal to 1 liter, 1 milliliter. So 1,000 centimeter cubes is equal to 1,000 milliliters. And if you convert 1,000 millimeters, it basically makes 1 liter. Yes, a question? Or maybe you want to summarize what I said? Hi, my host can unmute one person. Hello?
Hi.
Hi.
Can you hear me?
Yes, I can.
I just want to ask, sometimes you're breaking up. Can you speak slower, please?
Okay, I will speak slowly. There does seem to be some difficulty in the voice transmission because when one of the learners spoke as well, they were breaking up as well. Do you want me to go through this again?
Yes, please.
Okay, no problem. So we have the amount of mass that an object occupies is basically called volume. So let's say if we had to fill this cube with water, for example, now that would be how much of volume that is in this cube. Now volume is basically measured by multiplying the length, the width, and the height. So if we calculate the volume, we'll actually be able to calculate how much liters is filled into this cube. And we measure it by saying, before we measure the volume of this actual cube, I want to give you how to calculate the measurement of 1 milliliter. So 1 milliliter is basically equal to 1 centimeter cubed. And that we worked out by measuring the length, which was 1 centimeter, the width, which is 1 centimeter, and the height, which is 1 centimeter. So the volume of 1 milliliter is equal to 1 centimeter cubed. Hi, Tobago. Hello. Okay, I'll continue until
Yes,
you
ma'am.
unmute. Yes, you have a question?
Yes, ma'am. Ma'am,
Okay.
I don't understand. I don't understand the
volume. You don't
Yes, ma'am.
understand that? Okay. So basically what
Yes,
we
ma'am.
say, when you learned in earlier grades, you learned to calculate volume. Now volume is basically how much, let me put it like, you have a glass of water, right? And if you had to have a glass of water that measured 250 milliliters. So if we poured water into the glass, the amount of water right to the top would be the volume that fills the glass. Do you understand that? So now what we're going to do is we're going to see, instead of using a glass, we're going to use a cube, because I want you to be able to work out how we use a volume of a cube using centimeter cubes and then transferring it to working it out into liters. So if we had to take water and pour water all into this cube here, right? So let's say the water is going down in. Now, and if it fills it to the top. Now, if we had to work out the volume that this can hold, this cube, now because they gave us this unit of measurement, which is centimeters, so we're going to calculate volume in centimeters. So we take the length and we multiply it with the width and we multiply it with the height. And we get the answer of 1000 centimeters cubed. Now, when I told you earlier on, 1 centimeter cubed is actually equal to 1 milliliter. So we take 1000 centimeter cubes is basically equal to 1000 milliliters. So 1000 centimeter cubes is equal to 1000 millimeters. And this is something that you will have to learn by heart if you want to work out calculations when they give you different figures. So 1000 milliliters is actually also equal to 1 liter. So this is how we work out the volume of a cube, for example, in this instance. You need to change your mindset as to also not only know that volume is filled in a cylindrical substance, because volume can be filled in a cube, can be filled in a triangle, depends, it can be filled in any shape. But for you to know how to work it out, then you need to learn these measurements, like 1000 centimeter cubed is equal to 1000 milliliters. And then 1000 milliliters is equal to 1 liter. I'll ask my host to unmute one person. Hi.
Hi.
Hello.
Hello.
Can I answer a question for you or help you understand something better?
Yes, I want you to explain how you have to calculate the volume to get the millimeters.
Okay, so this is something that you have to learn. I'm just going to write here. My writing won't be very good, but you need to know that 1 centimeter, because I'm writing is not really good. I'm using a highlighter to write. So you have 1 centimeter cubed is basically equal to 1 milliliter. And you learned in previous grades that 1 liter, excuse me, is equal to 1000 ml. Sure, I'm writing like a first grader now. Okay, so now this 1 liter is equal to 1000 ml. So if 1 centimeter cubed is equal to 1 liter, then you need to know that 1000 centimeter cubed is equal to 1000 milliliters, which is equal to 1 liter. This is something that you have to learn in conversions when you're doing math. What I can do for you in my next lesson, I can put a whole lot of conversions for you to learn, and you can keep them and learn it so you know how to convert, and it will make it easier for you to learn. Okay. So when we're going to move on, you're welcome. If you're going to move on, density tells us how tightly packed a material is. Now, density is a measure of how much mass of a material fits into a given volume. So I'm going to say that again slowly. Density is a measure. That means that it's a measurement of how much of mass. So it's a measurement of mass that fits into a given volume. So if we look here at our picture here at the bottom, density is basically how much of matter. Like for example, if we're going to put in water, fits into this given volume of this cube. So when we say how much of mass fits in a given volume of cube, then we say density is a ratio between mass and volume. So the ratio is here. If you look in the equation at the bottom, mass over volume. So we we write this in a mathematical relationship to show the relationship. So density is equal to mass here and volume here. Okay, so you need to learn this formula by heart as well when you're going to calculate density. They'll give you the mass of something and they will give you the volume of something with the measurements, and like in say kilograms per liter. And then when you're going to write it, then your answer, whatever your answer is basically going to be your answer. And then let's just say you must always put the unit of measurements. You will have kilograms and then per, which is like a divided sign, liter. And then you write your answer like that. Okay. So when we use the symbol for density, now this we'll do in later lessons on. I'm just introducing to you the relationship of mass and volume to density and how it works. Okay, so we use the symbol, density is D, then mass is M, and then we have volume, which is V. And the equation that you're going to calculate density is basically density is equal to mass over volume. Okay, so the most important thing that you need to know for now for this lesson is, and then you can keep it in your mind and you can learn it very well. So when you're going to progressively do more difficult stuff, you know your foundation and you've built your foundational knowledge. So density is a measure of how much of mass is in a particular volume. And then this is how you work it out. And these are the symbols that you're going to. D is equal to M divided by V. These are the symbols you're going to use to calculate it. So you can take this down. I think the most important thing for you to take down is how much mass fits into a volume. Then density is equal to mass over volume. And if you're going to do it for short because you're going to calculate, then you can just do D is equal to M divided by V. Okay. So the materials with a higher mass will be more dense, and we say it has a higher density. So when we say that materials have a higher mass, we say that it is more dense. And when it is more dense, we say it has a higher density. Okay, so we're going to look at what we have next here. We can think of density as lightness and how heavy an object is of the same size. And you're going to ask yourself this question: what does she mean by if something has the same size, how can it be light and how can it be heavy? So we're going to investigate this in the next slide, but I want to take a question because I did see somebody has raised their hand. Any questions? I'll ask my host to unmute you if you need to ask me a question or you need clarity on something.
Hello, ma'am.
Hi.
Ma'am, I just I want to I've done some research about density in solids, liquids, and gases.
Okay.
And I've learned that solids have is very dense, liquids are less dense, and gases are almost not dense.
Okay.
Is that correct?
It is correct, but would you be able to explain why?
I think because a solid is compact, so that's why the particles are very near to each other. That's why it's
Very
dense.
good.
A liquid can move because of
Yes.
gravity, kinetic energy, and so forth. So that's why it's less dense, and gases are in the air, so they can move freely. I think that's why.
Yes, that's excellent. And this is what basically our lesson is on today, where I will go slowly and I will explain that concept to you. But well done on your research.
Thank you,
And
ma'am.
it shows that you're very dedicated. So well done for that. So
Thank you,
now
ma'am.
you're welcome. So now you're going to do density of different materials. Now, some materials have a low density and some materials have a high density. And now you're going to ask yourself, now how can that be? Now let's look at the example of the loaf of bread that has a lower density and a clay of bricks that is the same size. Now, do you think that the brick and the loaf of bread would have the same density? Now, the individual particles that make up one material may have different masses compared to the individual particles that make up another material. Now, in addition, there are spaces between the particles. Now, if you imagine the loaf of the bread and if you imagine the brick, now in the brick, the materials in the brick are really, really compact. They're next to each other, which makes the brick very hard. And then if you look at the loaf of bread, the loaf of bread is easily, you can break it easily. So that means that the particles in the material in that loaf of bread have spaces in between of them. So it makes it less dense as compared to the loaf of bread, even though they may be the same size. Okay. So the density of a material will depend on the kind of particles it is made up and the spaces between them, which is what I just explained to you. So I'm going to read this slowly so you can understand it again. And if you want, you are welcome to write it down. The density of a material, well, basically it will depend on the kind of particles it is made up of and also the size of spaces between them. So this is what makes something heavier than something else, even though they may have the same volume. So we're going to compare, and I'm going to use this way you're going to answer this question because I have explained it in the previous slide. You're going to compare the materials that have a same size, but it has a different density. So which materials is more dense, the loaf of bread or the clay of brick? Okay, the loaf of bread is the side, and then we have the brick. Now, they're the same size. Now, I want you to remember before you give me your answer, they're the same size, but then they have the same volume. Anybody would like to give me some feedback? I'll ask my host to unmute you. Hi.
Ma'am,
Yes,
can you go back a slide? I was still copying the sentence.
the sentence. Okay.
Yeah.
Let me know when you finish, then I will continue. But I can read it out to you as well. It will help you copy it. The density of a material will depend on the kind of particles it is made up of. So the density of a material, it will depend on the kind of particles it is made up of. And then the other factor is the size of the spaces between them. So the density of the material depends on the kind of the particles it's made up of and the size of the spaces between them.
Ma'am, I'm done. Thank you.
Done. You're welcome. Okay, so now questions as to explain to me why which one is heavy, is more dense, even though they're the same volume. I'll ask my host to unmute 2 people. We'll start with 1. Hi.
Good afternoon, ma'am.
Hello,
Good
ma'am.
afternoon. Hello. Okay, so one.
Ma'am, the brick is. Can you hear
Okay,
me?
I can hear you.
Yes, ma'am. The brick has more density because it's made up of a lot of particles.
Okay, and these particles, what happens, or how are they comprised? Or how are they situated in relation to each other?
The particles are more compressed in the brick than in the bread because the bread has more air gaps in between the particles.
Oh, excellent. Well done. I'm very proud of you. That's correct. Okay, so I will show it to you in a picture here. So in the brick, it has a high density because the particles are packed closely together. That means that there's not much space between the particles. And now in the loaf of bread, it has a low density because the particles are loosely packed together. That means that they are more spaces between each other. Does anyone else want to go through this, or are you fine with it? Okay, good. Yes. Hello.
Yes, ma'am. I was just saying that the particles are not also made from the same material, so that's why the
It's more dense and less dense.
yes, ma'am.
Yes, that's very good. Well done for that. But you look at the arrangement of it as well. One more person. I'm very happy with you guys. Well done. I'm happy that you participated, and I'm happy that you're eager to learn. Hello. Okay, so I will continue. So the brick would have a greater density, and if we compare the two objects of the same size, the one that is heavier, that means that it has more mass, has greater density. So may I continue, or we'll take one more person with a question with regards to this? Hi.
Hello, ma'am. Can you hear me?
I can hear you. Can you hear me? Hi. Okay, so I'll move on to the next slide. So we're going to say density and states of matter. So we learned basically that density has 3 states of matter and the properties of each. We have a solid, we have a liquid, and we have a gas. Okay, now we know that one of the ways in which the solid, the liquids, and the gases are different from each other is because of the distances between the particles in each respective state. So we can see here in the solid, there's less spaces between the particles in the solid. Then there's a little bit more spaces in the liquid, and there's a lot of spaces in the gas. Okay, the particles in a gas are much further apart than the particles in a solid or a liquid. So I'm going to say that again. The particles in a gas are much further apart than the particles in a solid and a liquid. And before I explain and I continue, who would like to tell me what it means in terms of density when I say the particles in a gas is much further apart than the particles in a liquid? So would the particles in a gas be more dense or less dense as compared to a liquid? I'll ask my host to unmute one person. Hi.
Hi.
I can hear you.
The particles are more dense in a solid than a liquid and a gas. It's less
Okay, so
dense in a gas
yes, less
than in a
dense.
solid.
Yes, that's excellent. Well done for that. So it's less dense in a gas as compared to the liquid and the solid. So does this mean that does this mean that the different states of matter have different densities? Now we're going to compare it in these 3 cubes. So they all have the same volume, and perhaps maybe we can say that it is the same material. Now container A, the particles are close together. Container B is, and it's in a solid state. Container B is in a liquid state, and container C is in a gaseous state. So we say the solid has the highest density because it has the greatest mass, because those particles were tightly compact next to each other in a definite shape. In the gas with the lowest density because it has the smallest mass, even though it is the same volume. That means that there were less particles in and less particles in the gas, and there were greater spaces in the gas. Now, liquids are slightly less dense because the solid particles in a solid state except in water. Now water is an exception, and let's see why it would be an exception. So the density of a solid material explains why it cannot be compressed, because the particles are solid, then they're tightly packed, and it cannot be squeezed closer together in a small volume. I will ask you a question when I'm finished the slide here. Right. So liquids are very dense. The density of liquids is rough, and it has the same density of a solid state of the same substance. And now this is because their particles are close together, even though they may be not locked in a fixed position. So most liquids cannot be compressed in smaller volumes. So we say most liquids cannot be compressed in smaller volumes. So have you ever wondered why ice cubes float in water? So you see this question here when I say liquids are slightly less dense than their solid states, but water is an exception. So now who can tell me why water would be an exception when we say ice cubes can float on top of water? Yes.
Hi, ma'am. So the reason why ice floats in water is because the water itself has a few air bubbles, but the ice also has, because during the freezing process, the ice collects gases.
Okay, so during the freezing process, when it arranges itself in a definite shape, that means that you have spaces in between the particles, right? So
Yes.
which means that's correct. So I'll explain it for you here, showing you the picture of an ice molecule, and then in a solid state, and then the picture of a water molecule in a liquid state. Now, the solid state of ice is less dense than the liquid because the ice in the water molecules are packed in a unique way. So now if you look at the picture of the ice in a solid state, the molecule, so you can see that there's lots of spaces in between as it freezes. So when the water molecules join together, it leaves some spaces in between. Now, when you see the water molecule in a liquid state, now remember how I showed you that when you wash your hands that they roll over each other and they slide over each other. So in a liquid state, the water molecules, they basically slide over each other, which makes it's because it's not in a definite state, that means that it is always moving. You won't get these definite gaps in between them as you would get in an ice. So this is why water is more dense than ice cubes, because of these definite spaces between them. So the image below on the left shows that water molecules in an ice are packed in a way that they have open spaces between them, which is what I showed you. And on the right, the water molecules show that is in a liquid state here, where there's not so many definite spaces between them because it's always moving. It's in a constant motion. So do you see that there are bigger spaces between the water molecules in a solid than in a liquid? And this also explains why icebergs float in water. Because you know you have those huge icebergs and they float in water. Now this is the reason why it floats in water and it doesn't sink. Okay, so we basically have about 3 minutes left. I want to do this gas, and before I finish this gas, let's just stop there before I do density in gases. Who wants to recap? Would anybody like to recap what I taught you so far?
Ma'am.
Hi. Yes, I'm here.
I mean liquid particles, ma'am. Does it automatically, ma'am, does it automatically turn into like in a pattern state?
I didn't understand fully. Does it automatically turn?
Like change into a pattern this way, in the way the atoms are.
Okay, now this is an example. Now the liquid pattern, this is a pattern to show you how it is in its liquid state. Now, if you take your hand, right, and put one hand over the other hand and roll it over each other. So this is basically how water molecules are arranged in water, because if you shake water, it's going to move. But when it's in a solid state, it means that it's fixed, it's compressed, it won't move. The molecules won't move at all. Like, for example, if you touch your desk, can you see that your desk won't move unless you shake it? So this is what we mean when it's in a solid state. So the molecules on your desk that makes up your desk are in a fixed shape. It cannot move. But then if you had to shake a glass of water, you can see that the water shakes, which means that the molecules can move. Does that answer your question?
Yes, ma'am. Thank you, ma'am.
Okay, you're welcome. So I'm going to give you homework again for one more question. Hi. Hello. Okay. I'm going to give you homework again today. You're going to summarize in, say, about 5 or 6 sentences what I taught you so far. And then when we start our lesson tomorrow, I'm going to ask you your summary, and we would continue with the density in gases, which would be me explaining this page to you. You can contact me on my email, which is ahaffea@gmail.com, if you need more questions. And there's one thing that I want to do before I go quickly. I was asked by our organizers for you to ask your parents to please go onto this website here, onto this link. See, it's forms.gle/aypumhg. Well, you can take this down and you can take a picture of it, and you can ask your parents to fill it in. This, it's a Google form, and it will keep a record of you. It's purely voluntary purposes as well. Keep a record of all the participants that we've had on our chat. And also, if you next week when we're doing our lessons, we won't be using Zoom. We'll be moving on to Teams, and we will send you the link for Teams. Okay. So I'll leave this on for a little while for you to take down this address, and don't forget that we're moving on to Teams too next week, Monday. Hi, any questions? Okay, so hello. I will take questions tomorrow, on Monday, sorry. I hope you have a lovely learning weekend. Enjoy the sunshine, go outside, take a walk, and also do some learning because it will keep your minds occupied. Right, have a lovely weekend. Goodbye. See you all on Monday. Bye.